A very good afternoon to all of you. I am Sutal Nayak from IIMT Group of College Greater Noida. I am working as assistant professor in BTech EC department. Today, I am going to present uh, the instruction set of 8085 microprocessor. In the last video, we discussed addressing modes of 8085 microprocessor and overview and an introduction of 8085 microprocessor. As we all know, 8085 microprocessor is a 8-bit microprocessor and it has 16-bit address line. Now, how we communicate, how we perform the task, assigned task by the microprocessor with the help of instructions. Today we will discuss the instruction set of 8085 microprocessor. Now, first of all, what is this instruction? An instruction is a binary pattern designed inside a microprocessor to perform a specific function. The entire group of instructions that a microprocessor supports is called instruction set. 8085 microprocessor has 246 instructions. Each instruction is represented by an 8-bit binary value. Means every microprocessor, it may be 8085 microprocessor, it may be 8086 microprocessor, it may be 80186, 286 or any. These microprocessors introduced by Intel company. Every microprocessor have their unique instruction set and every instruction have their opcode, operation code or a hexadecimal number. This number in pattern like 1 and 0 only. Each instruction is represented by an 8-bit binary value. 8 bits is equal to 1 byte. These 8 bits of binary value is called opcode or instruction byte or hexadecimal code for a particular instruction. Now these instruction set of 8085 microprocessor is classified in various groups. First group is data transfer group or data transfer instruction. Second one is arithmetic instruction. Next one is logical instruction, and next one have branching instruction, and last one is control instructions. Today we are here to discuss the data transfer instruction. In data transfer instruction, we communicate data between microprocessor and memory, between microprocessor and input-output devices. These instructions move data bytes, registers, or between memory and registers also. Means with the help of data transfer instruction, we transfer data between register to register also. For example, in 8085 microprocessor, we have journal purpose registers like register B, register C, register D, register E, register H and L. These 6 journal purpose registers, all registers are of 8 bits only. Means every register will contain 8 bits, and another register is accumulator. Accumulator will store the result also. It is a 8-bit register. It stores 8-bit data also, as simple as the function of the general purpose register, and it is used with the central CPU also. Arithmetical and logical operations is performed with the help of accumulator only. These instructions copy data from source to destination. While copying, the contents of source are not modified. Means when we copy the data from one register to another register or source register to destination register, then the data will not be modified. Now, data transfer instruction. First instruction of data transfer group, that is MOV. This is the opcode for this instruction, and our whole instruction is MOV RD, RS, where RD is the destination register and RS is the source register. Uh, this instruction will copy the data from the source register to destination register, and this is a 1 byte instruction. Means this whole instructions contains only a opcode or a hexadecimal number which will perform this task in microprocessor with the help of microprocessor. Hence, MOV can be used in another way with the memory also. MOV M comma RS. MOV M comma RS. This instruction copies the data of source register into memory. Memory. What is the meaning of this memory? What is the meaning of this M here? Now, this M represents the memory location which is specified by the contents of HL register pair. Means in our general purpose register, we have a register pair, that is register H and L. The combination of these both register H and L will contain the 16-bit data, and this 16-bit represent any memory location, and the data from the source register. The source register may be an accumulator, register B, register C, register D, register E. From the any source register, our data will move from the source register to memory location, which is specified by the contents of HL register pair. For example, MOV M comma B means the contents of register B will move into register M data. Yeah, memory pointer data. Okay. Now, next instruction is MV. Okay. In the same manner, MOVRD comma M also means the contents of memory location will move into destination register. This is nothing. This is the vice versa of previous instruction only. Now our next instruction is MVI RD comma data. In the same manner, MVI M comma data. Means with the help of this instruction MVI RD comma data, we move immediately. What is the meaning of this MVI? Move immediately 8-bit data into destination register. And this RD, this destination register means any register, register B, register C, register D, register H and L. Okay. And accumulator also, with the help of this instruction, we can move data into accumulator directly. Means any 8-bit data we can move in any general purpose register and accumulator also. MVI instruction is used to move 8-bit data. Okay, getting my point? We have 6 general purpose registers and 1 accumulator. All these registers are of 8-bit only. And with the help of this register, we transfer 8-bit data into any register. Okay, for example, MVI B comma 57H means 57 hexadecimal number immediately will move into register B. After execution of this instruction, 57 will be moved into register B. Means now what will be the content of register B if we break this 57 into if we convert this 57 hexadecimal into binary. Now what will be the contents of register B? In this case, after execution of MVIB comma 57H, the contents of register B will be 0 1 0 1 0 1 1 1. Okay. Now after execution of this instruction, our content will be changed as 57H hexadecimal number. The 8-bit data is stored in destination register or memory also in this case. And now in case of memory, how we transfer the data into memory and what will be the aim? is as the same as we discussed in the last instruction. What is M? M is nothing. It is the operand, is a memory location. Its location is specified by the contents of the HL register pair. Means, for example, we have in HL register pair 8000 because the pair is 16 bit. That's why we are taking 16-bit data here. Okay, and for example, if we take the contents of HL register pair, that is 8000, means now what will happen if we use MVI M comma any 8-bit data. For example, it's 57H. Means now what is our instruction? That is MVI M comma 57H. Now what will be the contents of M after execution of this instruction? The contents of our memory location, that is 8000, will be 57H. Okay, means if we want to move immediately data into memory location, we will use MVI. This instruction is used for immediately move of 8-bit data only. Now, next instruction, that is LDA. LDA, load accumulator directly. Okay, load accumulator directly with 16-bit address. Now, for example, we have an instruction that is LDA 2034. Now, from the memory location 8085 microprocessor, we have 16-bit memory location or 16-bit memory address lines. For example, in this case, we have taken 2034. This 2034H is here a address of any memory location. Okay. Now, what is the data? For example, 2034 contain 08. This 08 will move into accumulator, or this 08 will be loaded into accumulator. Means, what is the meaning of this instruction? Load accumulator directly from any memory location. We can take any memory location from 0000 to FFFF memory range. This is our memory range for 8085 microprocessor, that is 64K micro. Okay, and this is a 3-byte instruction also, which is we already discussed. Now, next instruction is LDAXRP. Again, I am going to repeat LDAXRP. This is the instruction. RP means register pair, and in 8085 microprocessor we have register pair BC and DE. And what is the meaning of this instruction? This instruction will do the same thing. I'm repeating my words again. This instruction will do the same thing like as LDA 16-bit. But in LDA 16-bit, we specified our memory address by 16-bit. In this case, the content of the designated register pair point to a memory location. For example, LDAXB. Okay, means we load the contents of register BC, means which data. For example, our BC contained 8000. For example, the contents of register B and C is 8000. The data of this memory location, for example, this memory location contains the data 04. This 04 will be loaded or will be transferred into accumulator with the help of this instruction. Now, what is the requirement of this instruction? We have already LDA for the same thing. But LDA is a 3-byte instruction, means LDA, simple LDA instruction will take more time to execute, and this LDA XRP, yani load extended register pair by accumulator directly. This instruction is only a 1-byte instruction, and this instruction executes the same thing in a very fast manner. Okay. Now, next instruction is LXI, load extended register pair immediately. Load extended register pair immediately with 16-bit. What is the meaning of this instruction? What will this instruction will perform? That is, with the help of this instruction, we immediately load 16-bit into any register pair. And in 8085 microprocessor, we have 3 register pair B or C, register pair D, E, H, L. Okay. And how we use this instruction? For example, LXI H comma 2034H. This 2034H, this last H represent that is the hexadecimal number, means 2034 is a hexadecimal number, and this 16-bit will move into register pair H and L. In the instruction, we don't specify L here, we write only H, and in assembly language programming, all the instructions must be in the capital letters only. Okay. Now, LXI H comma 2034. Now, after execution of this instruction, register H will contain 20 and register L will contain 34. Means HL and register pair will contain 16-bit data, that is 2034, with the help of LXI instruction. Now, we can relate this, how we learn these instructions. We have a lot of instructions in 8085 microprocessor. We have to relate our instructions. Means if, for example, for 8-bit data transfer, we use FPI instruction. For 16-bit data transfer immediately, we use LXI instruction. Okay. Now, next instruction is LHL D, load HL registers directly. LHLD 16-bit address. This instruction copies the content of memory location which is pointed out by 16-bit address into register L. It copies the content of next memory location into register H. For example, LHLD 2040H, means with the help of this instruction LHLD, we load HL registers directly with the specified memory location and the next one memory location also. Data transfer instruction, the next and most important instruction, that is STA 16-bit address. This instruction stores the contents of accumulator at any given memory location, from ranges from 0000 to FFFH. Okay, with the help of this instruction, for example, if we add some data, if we subtract any data, the result will be stored in accumulator. Now, the result directly will be stored in any memory location with the help of this instruction. STA store the contents of accumulator at 16-bit memory address. For example, STA 2500H means the content of, for example, we have content in accumulator, that is 08. Because we are talking about hexadecimal number, we have to take 8-bit. So which number I have taken in accumulator, that is 08. Now with the help of this instruction or after execution of this instruction, we transfer R0A, we store R0A at the memory location, that is 2500. Okay, again I am repeating, STA2500H. Store the content of accumulator, that is 0A, into memory location 2500H. Next, STAX register pair or RB. This instruction will do the same thing, but in the same manner. STA 16-bit was the 3-byte instruction, and STAX RB register pair, this is the 1-byte instruction. This instruction also perform the same thing, but with the help of register pair. STAX store the contents of accumulator at the memory location which is specified by the contents of register pair. For example, STAXB means if the contents of register B is 8040, now the content of accumulator will be stored at 8040 memory location, but with the help of a single, yani 1-byte instruction only. Means execution time will be very less for this instruction, speed will be high. Okay, because this is a 1-byte instruction, only a single, yani 8-bit opcode will be sufficient, hexadecimal code will be sufficient to run this task. Now, next instruction is SHLD, 16-bit address. Store HL register pair directly. In the same manner, LHLD, this instruction is used to store. This instruction is used to store the HL register pair directly. The contents of register L are stored into memory location specified by the 16-bit address. The contents of register H are stored into the next memory location. For example, SHLD2550H. This is the example for the SHLD instruction. Now, next one is the XCHG, and operand is none in this case. Means this is the single instruction, we don't have any operand in this instruction. This is simple and a 1-byte instruction. Means we have a single opcode for this XCHG only. What will this instruction will perform? That it exchange the content of register HL with the contents of register DE. Okay, means if we want to exchange the contents of HL register pair with DE register pair, we use XCHG instruction, and this the contents of register H are exchanged with the contents of register D. The contents of register L are exchanged with the contents of register E. XCHD is simple instruction, there are no any operand. Okay. Now next is STHL. Again, in front of this instruction there are no any operand. This is a simple 1-byte instruction. STHL. This instruction copy HL register pair to the stack pointer. This instruction loads the content of HL pair into stack pointer. Okay, with this is also a 1-byte instruction, and with the help of this instruction we can transfer data between stack pointer and register pair HL. Stack pointer is a memory pointer, and this is a 16-bit register, and HL register pair, the combination of register H and register L is also a 16-bit. Hence, we copy the contents of HL register pair to the stack pointer with the help of SPHL. Now, next instruction is XTHL and operand is none in this case also. This is a 1 byte instruction because we don't have any operand in this instruction. Also, we have a simple opcode that is XTHL in this case also. Exchange HL with the top of stack. This instruction is used to exchange HL with top of stack. This instruction is used with the stack pointer also. The content of L register are exchanged with the location pointed out by the contents of stack pointer. The contents of H register are exchanged with the next location and the contents of a stack pointer plus 1 with the help of this instruction. And for the stack operations, we have push and pop instructions also. Now, next one is PCHL. Again, operand is nothing. This is a 1 byte instruction. This instruction is used to load program counter with the contents of HL register pair. Now, with the help of this instruction, we load the program counter. What is program counter? Program counter is a 16-bit register and this is a memory pointer. Means program counter have some memory address also. Now with the help of this instruction, we load program counter with the contents of HL memory, HL contents. Now, these all instructions were used between the data transfer between microprocessor registers and memory to microprocessor or microprocessor to memory. Now we have two instructions in IN and OUT. These two instructions are used to data transfer between input output devices and microprocessor. Means with the help of these two instructions, we transfer the data between input output devices and microprocessor. Now, first one instruction, that is OUT, 8-bit port address. In 8085 microprocessor, we have 8-bit port address, means we have ranges from 00 to FFH for the port addresses. Okay. Now, with the help of this instruction, means out 8-bit, any 8-bit, 7, 8, 8, 8, this instruction copy the data from accumulator to the port with 8-bit address. The contents of accumulator are copied into the input output port with the help of this instruction. This is a 2 byte instruction. Next one is the IN 8-bit port. This instruction copy data to accumulator from the input output port with 8-bit address. As we have 8-bit address, for example, IN8CH. Thank you very much. The last instruction of data transfer.